In this video, I show you how assembly program is executed using Keil microvision and what are the mistakes that your program is not run while it's so no error and no warning. So first, doing program in assembly language, you have to go that project, then select new microvision project and make a folder, new folder for your test, that experiment folder, that all details I have saved in this folder. They keep the name experiment. Now save it. Without any extension you have to save. If you give some extension, then there will be some error. So save it. The next step, you have to select the target microcontrollers, that is device, and I use that AT89C51, that most common microcontroller. So don't select this button. Okay, use extended linker is not select. Now double click here. Okay, here there is option that copy startup.a51 to project folder and add file to the project. You have to select no. Why no? Because it create extra bit. Now we have to add a text file. You can select from here file, new, or by clicking here, that is Control N, new. So new text file is open. You have to save it with extension .asm. Now I already write the code. In your book or some program, that org00h is not written. Okay, so start from the directly from here. But I recommended that you write that org00h to declare that. And sometimes due to this, your program may not be debugged fully. So after that, you have to save this file with extended as ASM. Now save it. This is my folder. Now write exp1.asm without any gap. But if it is ASM, then save it .asm. Now you have to add this file here. Add existing files to group source group 1. Add it. Sometimes it's not appear, then select the all files, then .asm will appear. Add it. So look at that exp1.asm is included. Now save it. Then build that second button. Okay, that button, build F7. That zero error, zero warning. Okay, if you remove this 00H, what happened? Again build it. That zero error, zero warning. So first I try that not using 00H. So my program is compiled. I rebuild again. That it is the right code. Then go to debug. Now it shows that evaluation mode running with code size limit 2K. So look at, there is no error. But in previous version, there will be error. Why? Because if you not include 00H, then it shows the error. Now run it, that is run F5. So program is start running. To look its output is complementary P1.5. Actually, this is a program for toggling a pin 1.5 to generate 50% duty cycle square pulse. So the code is already run. To check its output, you have to go peripheral, then IO port. Since it's connected with P1.5, select port 1, then look at that it is running. Now stop the program. Look at, this is stopped. Now run once again. Look at, this is run. To check it using the analyzer, click on this button, analysis window. Now extend this analysis window. For analysis window, you have to select the port. First you have to set up the port. To go to the setup, then click the logic analyzer signals. So new insert, don't delete, and new insert. So a new insert, port P1.5. Okay, enter, click once again and select, this is the straight line because we select the analog. Now you select the bit. Okay, close it. Now zoom it. Look at, this is the 50% duty cycle square pulse. So this is the common problem. Another problems we found that sometimes you write O instead of 0. So if you write O, that it looks similar. So be careful when you build it that it is undefined. Why? That it is unexpected symbol here. So you have to remove O and put 0. That is, we can replace this with 0. Again, look at the color is changed. So build, no error. Another mistake, that if you not include 0 before A, B, C, D, E, F, that is when you write the hexadecimal code, that it's preceding obviously 0. Not in the right side, only for the left side. If we started with F, A, B, C, D, E, then you have to delete this and insert 0 before it. Now I want to check that what happens if I write 00H ORG 00H. Build, no error, no warning. Go to the debug window. Look at, there is no error. Run it, that it's work. Now if I select Yes, in my previous, in starting, that is .asm. So start again project, new microvision project, okay, exp now 2 means it work. Now go to the debug, let's check what happened. Run it. Go to the peripheral, IO port, look at it's work. Again, I select the another option, project, new microvision project, experiment 3, save, select the microcontroller AT89C51, okay, select yes, look at that startup.a51 is here, write the code, since it is already there, so just include it, right click on the source group 1, existing file, experiment1.asm, add it, close, build. I say that no, because it's not required. So build this with startup.a51. Look at 0 error but 3 warning. So the warning is appear when you use this A51, and this code will not debug properly. You overruled it. So when the warning appear, please remove that file. How you remove? Stop debugging, remove, right click, then remove file. Again build it. So every time when you change the program, you have to build, otherwise it loads the previous section. Look at that, 0 errors, 0 warning. Now when it's appear, then you have to the extended files. So how? For that, you have to select this option for target. Means once you write the program, you can change the device. Look at this device which is appear. Now you use the extended linker to instead of BL51 and use extended assembler instead of A51. So you have this option, this. So now if you build this program, it shows 0 errors, 0 warning. You can build from here also. Rebuild all target files. And the rest of the procedure, same. In this way, you can program Keil using assembly level language. That's all.